let's jump right in. All right, thanks everybody for joining. We're excited to reform the Silicon Valley chapter of the Cloud Security Alliance. I'll talk just briefly for a few minutes about what that means and kind of what the journey looks like going forward. First, maybe let me ask everyone who's on the new board to introduce themselves. Vishwas, let's start with you, and then let's kind of proceed through that. That'll be about a minute, and then we'll continue.
Sure. So I can introduce myself. I'm now the chair of the Cloud Security Alliance. In the previous incarnation of this board, I was actually the vice chair. I think what has happened over the last year and a half has been that we haven't had too many events, and one of the reasons has been that the chair of the Cloud Security Alliance in Silicon Valley actually had to move out of the Bay Area and into Seattle, and because of that we were pretty passive. And then because of Corona and COVID and so on, we were not doing much for the last 6 months. We actually reformed the board, and I'm now the chair of it. I was earlier like I said, the vice chair. I was the CEO of a company called NanoSec. We got acquired by McAfee about a year back. So that's in brief of my background. I'm a technologist, and I'll also be speaking today.
Thank you, Vishwas. Mayushmi, can you go next?
Moshmi, I think he's mentioning you.
Hey, I was on mute. Hi, my name is Moshmi. I am a board member of CSA Silicon Valley. Currently, I am at Okta. I'm a software architect at Okta. My background is in the identity management at Nutanix and Oracle, and I look forward to collaborating with you guys. Thanks.
Thank you. Himanshu, can you go next?
Yes, thanks, Mike. Hi, everyone. My name is Himanshu Dwivedi. Happy to be here. Been in security for a very long time with companies like AtStake, co-founded ISEC Partners, and then Data Theorem. And so happy to be on the board. Cloud security is something that I'm very passionate about in terms of how the application moves from the old way on-prem to the cloud. So everyone, thanks for having me. We're going to have a lot of good research talks on this event or on this series. And if you have any questions, feel free to let me know. But again, Himanshu from Data Theorem, and looking forward to, I guess, working and sharing ideas with all of you.
Thank you, Himanshu. Sem, can you go next?
Sure. Hi. My name is Gürkök, and I'm working with these great folks getting the Cloud Security Alliance Silicon Valley chapter up and running again. It's been great to be part of this team. And my main focus is cloud security and container security. And been working on various companies such as Salesforce, Facebook, and security has been a passion of mine for a very long time. And it's great to be on the bleeding edge of these things and helping out the community to adopt all the fun security measures. And today I'll also be talking right after Vishwas around the customer view of cloud security challenges. So feel free to ask questions after the talk, during the talk, or we can sync up later. Thank you.
Thank you, Jen. We do have another board member. His name is Piyush. I don't see him present in this meeting right now, so we'll skip over him. And Piyush, if I missed you, please shout out your name. I'll go last. I'm Mike Machado. I lead cybersecurity at RingCentral. I'm the vice chair of our new chapter, and I've been doing security with cloud services and cloud businesses for enough years that it would be embarrassing to give a number. I'm really looking forward to being part of this journey with all of us, and I'll sort of wrap up by saying this is your chapter, right? We've set up these talks as an initial starting point. Because we needed a starting point, but we intend to follow up and gauge your interest in a series of topics so that we can prioritize those talks. We welcome you to volunteer to be the speaker or to suggest someone you think is a really strong candidate to present these topics if you want to be a learner. But most importantly, we want you to know that we're going to be reaching out to you all to take your lead on the direction, because this is intended to serve your needs, and we hope to be the change agents to make this what you need it to be in terms of a chapter. Our priorities are knowledge sharing, one, research and education, two, three, community involvement, and those are kind of where we're starting out. We'll seek your feedback for other areas, as the time progresses, but we'll try and do that at a cadence that allows us for us to walk first and then run, and that's kind of the vision for convening us all together. The process is that we have affiliated with the national body of the Cloud Security Alliance. There's a 12-month cycle where we're essentially a preliminary chapter, after which we can become a permanent chapter, so long as we've had a cadence of the chapter existing over the course of those 12 months. Where we're generally thinking that we'll meet monthly, but again, this is your chapter, and we'll want your feedback on the right and appropriate cadence. And indeed, whether there even need to be sub meetings from time to time for more specialized topics that the larger group may not have a great deal of interest in. So that's sort of by way of introduction. I'm going to be the moderator in today's gathering. If you have a question, raise your hand. If you want to send some chat, I'll be sure to share that and make sure we're answering your questions. For now, I will pause. We'll hand it over to Vishwas, who's going to start on our first talk. Thank you very much, Vishwas.
Hey, absolutely. Thank you, Mike. That was you moderated very well. Thank you for giving the introductions on behalf of everybody, telling about the chapter and what we plan to do. I think that's great. I think I will jump right into the presentation, and I'll let me know if you see my presentation, and I will sort of talk through it. The idea being, I will just run through the slides, and if people have any comments or questions, we can sort of take it from there. Like Mike mentioned, right? We started out this chapter saying, okay, we restarted this thing saying, okay, where do we do our first meetup? And the first thought that came to our mind is we have to start off at a level where it's very, at a very high level, looking at what was cloud before, how is it changing, where is it headed? And that's where, I took up the burden and said, okay, guys, I'm willing to take this up, and if nobody else is, and here I am sort of talking to you about, what the future of cloud and containers. The idea is very simple, right? We're going to say where it started, maybe starting with NIST 800, 145, I guess, which is where cloud computing got defined. Moving on to, what happened in SaaS, what's happened in IaaS and PaaS since, and, how is the cloud and the cloud infrastructure itself evolving, and what does it mean for security as we see it, right? And so let's get going. So this is where we all started. Like I said, NIST 800, 145, 2011 timeframe. We had, various models of cloud delivery. We had IaaS, there was PaaS, there was SaaS. Right? We all know about it. It's well known. IaaS is where you actually, the application owner, who was the user of the cloud, would not just create the application, but would also take care of configuring, the host, the network, the compute, the storage, a lot of other things. And you could host any application, right? Your own arbitrary application, and it would work. On the other side of the fence was the SaaS, right? SaaS is basically where the cloud provider is actually hosting an application for you, and what you are doing is deciding on who has access to the application, as well as any data and other critical things that that are stored in the infrastructure. So that's SaaS, which is SaaS is basically, as we all know, right? It's an application that is already created, and you're consuming it through a REST interface or through the internet, right? And on the other side was IaaS, where you had to do a lot of things to build your own arbitrary app. And in between these two was PaaS, of course, right? It's not that you had to, in PaaS, you did not necessarily have to do all the work that you had to do for IaaS, but you now built your applications on a platform, and a platform did a lot of things for you. So you could build your own arbitrary app, but what would happen is you did not necessarily control the host, OS, the storage, the compute, and you've got various different flavors for it. And as we talk about it in the again, as I move forward in the discussion, I'll talk about the various models where there's container as a service, there's a control plane as a service, right, for the service plane and so on. So there's a lot of changes that are happening, but this is where it all started. But what has happened since, right? Cloud has been used to deliver value faster. We all know, right, whether it's IT companies or whether it is ride hailing companies or whether it is hotel companies, software and becomes a critical differentiator. IT teams or security teams are being pressurized to be more and more agile, being able to deliver value faster to the customer, to be able to deliver value before competitors, to be able to deliver value consistently, right? And what is ended up happening is there's a lot of let me just, sorry, there are people trying to join in. I just want to enable them. This is a problem for me today. Okay, so what is happening as a result is a lot of there's a lot of the speed of innovation is very fast, and and that is resulting in that I feel, and that's my thought, right, that because people have to deliver value, we need to deliver innovation faster, which is causing the biggest disruptions in the cloud. And that is what we'll talk about in the following slides. What does it mean, right? But let's look at it from an enterprise perspective. Cloud is one angle of it, but if I look at it from an enterprise perspective, the things that we see are this, right? To deliver value faster, and because software becomes a key way of delivering that value, right? Like I said, the ride-hailing companies are, are the key differentiation is the software, whether it is the hotel company, right, or the shared services model. It's all about the software. Software becomes the key differentiator. So what it means to deliver value faster means to be able to let developers work and deliver things faster, bring it from code to production faster. And what that in turn means is the ecosystem around it has to help in this development, right? So how do we enable these developers to deliver value faster, which means security, which used to come in the way, has to sort of modify itself to sort of enable the movement of to faster movement instead of being a hindrance, right? And that's how we see it. If you look at the cloud ecosystem, it's also evolving considerably with CI/CD, infrastructure as code, configuration as code, policy as code, as you see it, right? It's become a lot of things are getting automated instead of being human readable. Everything where humans were actually in charge, becoming more and more automated with a lot of things that now being taken over by software. That's how we see the enterprise transformation and what it means from an application strategy, right? And we'll go into the cloud part next. But from an application strategy perspective, what we see is the SaaS. We are seeing changes in the SaaS. What SaaS used to be earlier just horizontal SaaS, right? So your typical application that was in your enterprise is now residing in the cloud. That is what horizontal SaaS was. Right? Typical application that is residing in your on-prem data center is now moved to the cloud, and it's actually being delivered through the cloud as an HTTP sort of as an HTTP endpoint, right? But that's what horizontal SaaS was, and that's how it all started. But what we are seeing now is the rise of vertical SaaS companies like Twilio, which are not, or even RingCentral, I guess, right? And you see Stripe and others, which are not actually a complete application, but actually parts of the application, right? Instead of being a horizontal application, it's like, hey, I'm with the Twilio or RingCentral or others. It's all about, hey, I delivered to you through APIs, unified collaboration as a service, right? So you could, with the SDK, with some changes and some calls to APIs, you would actually be able to embed into your applications, SMS, you would be able to embed, phone calling and everything else, right? And that's where we see a big change that is happening on the SaaS side. And what enterprises are trying to do is trying to adopt SaaS wherever possible. That's where I see it, right? So people are trying to adopt SaaS wherever possible. That means, hey, if there is a choice, when I have to host a SaaS application myself versus keeping it, consuming it as a service, we see enterprises slowly, even banks, moving toward that model, saying, you know what, unless it's a business differentiation, let me try to use SaaS wherever possible. And the IaaS PaaS side is where people are building their own applications, and they're only building their own application for things that they think are business critical, that are differentiating, that is critical for them. And in this case, it means being able to deliver the value faster in the faster. And so what we are seeing is there's a big merging in IaaS and PaaS, and I'll talk about it further. And we still see a lot. And our take is, maybe 80 to 90% of the workloads are still in on-prem. A lot of companies, right? If you especially look at the bigger, more traditional companies, 80-90% of the workload are still there. And what we are seeing is, yes, there is a migration, and there are companies, the cloud companies, coming up with on-prem solutions for the cloud, right? So you see Amazon coming, or Azure coming out with Arc, or GCP coming out with Anthos, which is, hey, I'm actually now going to provide you software in your data center that can help you treat your data center as if it was working like a cloud, right? And we see a lot of that, but there are a lot of applications that are still going to be residing in the data center, and it's going to be mainly legacy applications, things that are critical because of certain reasons where you cannot give it to build it and put it in the cloud, or in certain cases they're hard to migrate. And that's how I see it, and that's how we see the enterprise point of view. And then I'll move into I think the next set of slides are more about how we see the changes in from a cloud perspective in the SaaS and the IaaS and PaaS and containers and so on. Even before I go there, I wanted to sort of open up to any questions that there may be. Any questions, guys, or any comments?
There are no questions in the chat right now, Vishwas.
Okay.
If anybody does have questions, please speak up.
Okay, so we'll move on to the SaaS, right? And like I said, what the enterprises are doing, they want to adopt SaaS wherever possible, right? And so what we are seeing from a SaaS perspective is there's a huge growth of SaaS in the enterprise. That means there's a long tail SaaS. It's not just about Workday and Salesforce and others. People are using SaaS for even a lot of other functions. So I think there are surveys that said enterprises in general are using about hundreds, I think even thousands of SaaS services, right? And that's where we see. So there's a long tail of SaaS usage, which is what security teams now need to look at, which means it's not just about securing your top 5 SaaS services. You now need to look at the long tail of SaaS. There's now a broad adoption of SaaS, and so you need to look at it. There's now a lot of API and cross-app data that is being sort of created, because people are now, when building apps, they're in a lot of cases, like I gave you the example, Twilio or Stripe or Plaid and others, people are actually now calling APIs that are now provided as a SaaS service, right? APIs as a SaaS service. And so this SaaS is not just going to be about just your applications. It's also in a lot of cases going to be about APIs to these applications to get particular functions. And we're going to see a lot of unsanctioned apps, right? So security team may or may not approve of every SaaS application, but we see a lot of it. In fact, I'll give an example of this. I talked to, he's a VP at a big healthcare company, and this guy told me, right, the thing that I want on SaaS, right, you guys, is this, right? Tell me, so for him, he says, new apps are being deployed on a regular basis, and on every sort of, on a, maybe I get in at some point of time, and on a Friday, and a new app comes in, and I'm told by the company saying, hey, we need to deploy this app on a Monday. Can you give me, is security going to approve this? Do you have any questions around this, right? Or would you approve it? And what this guy asked me was, hey, could you give me some measure of security risk when using a particular SaaS application or using a particular API? And I want to sort of be able to, at least, even if I can't block it, at least give the risks, bring it up in front of our our management committee. So at least my side, I've done my work. And in the extreme case, if you tell me things are really bad, I want to be able to give me that thing in terms of data, and I would be able to approve or disapprove moving towards usage of those apps. That's how we see SaaS evolving and SaaS moving. Any questions there? And I can probably move forward, right? And so this is in short of what I already, or this is in points of what I already mentioned, right? In the old, we were talking about software is eating the world. We are seeing a lot of it now. APIs is becoming a big critical thing, even for SaaS, right? We are seeing from functionality perspective, it was traditional business software delivered to cloud, which was what I was called horizontal SaaS. This is how SaaS was before. they are moving towards the vertical SaaS model, right? A lot of APIs being exposed. In a lot of cases, even our in-house apps using APIs, right, and building things. And security, what used to be more bolt-on, right? You build security after the fact. You now have to build in security when the apps are getting delivered, because now we're talking about APIs, right? We have to build in security there. And then the traffic in a lot of cases is not going to be a user to app traffic. It's going to be a lot of app to app traffic that you as a security team need to look at. And so that's how we see SaaS. That is how we see SaaS evolving in the last maybe since 2011 or 2000, in the last 4 or 5 years. This is how we've seen SaaS evolve, and security implications are the same. Any questions there? And if not, okay, so let's get to the last part of it. I think the last part of before I move to the IaaS PaaS is this, right? So from a SaaS security perspective, we see, we need to look at not just like I already mentioned, look at sanctioned apps. You need to look at APIs. You need to look at DLP. You need to look at identify threats now for not just SaaS applications but for APIs them too, right? You need to be able to look at the fact that now developers are going to be also using SaaS. It's not just going to be, hey, IT companies or your own end user applications. It's going to be a lot of SaaS usage where developers are going to be calling SaaS APIs. So you got to look at all that to sort of move forward. And moving forward, what we see and what I see, right, is that the growth of SaaS is just going to increase even further, right? As we have to deliver value faster. There's going to be a growth of long tail SaaS, and there's going to be a lot of changes in how we are going to deal with SaaS. Any questions or comments there? And I can then move on to IaaS and PaaS and so on. Okay, so let's move to changes in IaaS and PaaS. And I think this actually this was a diagram that I created for CSA European Summit, but this actually shows up very well with showing what has happened. Like I said, when developers need to develop things faster, we had IaaS, we had PaaS, and we had SaaS earlier. But developers need to develop things faster, and they have different kinds of applications, and they have different kinds of controls that they need. In certain cases, hey, it's a simple application. I do not even need to write code. So there are actually models of no code that are coming up from cloud providers, right? And I think there's things called Honeycode or Honeycomb, I guess. It's AWS. There's similar things from Google and others where you put specification in an Excel sheet and the app gets delivered, right? Created your custom app, but now delivered, created without you ever having to write code. And on the other side, you have things like Kubernetes as a service, which is about, hey, we manage your service control plane. You still need to manage your applications, but you do not need to manage a lot of the things like scaling in, scaling out. You do not need to manage the updates of the control plane and so on. And in the middle, you have things like function as a service, which is what we call lambdas, right? Which you write the code, you provide the code, right? And it's actually built as containers and actually deployed. And then you have containers as a service where you actually give things as containers. So you've got a huge variety of things. And the big reason you've got a variety of things is when you have different kinds of apps, you need all sorts of different infrastructures to be able to deploy these apps. And what service providers are slowly doing is providing you more and more of these models. So the more and more flexibility based on what you need, right? And what I see moving forward is there's going to be more and more push going towards the right. That is, you go to a no code or FAS or CAS from a model of IaaS where you actually had to manage the network, security, everything else, right? Things are moving from
IaaS. So let me interrupt you really quick. Sorry, we do have a hand raised with maybe a question. So let's cover it if we can.
Sure.
Let's see. This person may have actually dropped off. So they were here, raised their hand, but have since gone. So sorry to interrupt you. Let's please continue.
Okay.
Yeah,
go ahead.
Hi.
Go ahead.
Yeah, go ahead. Yeah. So actually, there's a lot of echo coming. Those who are not speaking, please they mute their mics because it's kind of a lot of echo when you speak.
Got it. Yep. Makes sense.
Thank you. And Vishali, did I get that name right? I saw your hand up. Did you have a question or a comment that you'd like to share?
Yeah, that was the comment because I was not able to.
That was you.
Because of echo. Probably.
Got it. Thank you very much.
Okay.
All right.
Great. I mean, yeah. So that's where that's sort of the big evolution that I see from a IaaS and PaaS perspective. There's been a merging of IaaS and PaaS as I see it, right? And it's not just IaaS and PaaS. Now you have like tons of different platforms to build your applications, and things are going towards the right, which means things are moving towards, a developer has to do less and less, a DevOps has to do less and less, and more and more weight or work is being taken up by your software, right? Of course, you need to know how to configure the software, which is where the fun is, right? Because that's where the challenges are, and everything is not as easy as it seems. But that's the direction in which we see the movement in the IaaS and PaaS side. Right. So let me get to the next thing, right? So basically,
Vishwas, I would like to pause you for a second again. This thing is pretty annoying. Somebody's thing is really echoing quite a bit. You want to mute everyone since you have control on it?
Sure. Let me see. I'd see.
Yeah, most people are muted. We have a handful of people who are not muted. So Vishwas, we can just mute them.
Sure, I can do that, Tip. I don't see too many others. That's the only one. Okay, there's only one that was unmuted, so I've got that unmuted. Muted. Yeah, okay. Looks like this is better.
I don't hear the echo anymore. Great.
Great. Okay. So I think we talked about, the idea of what is happening with the IaaS and PaaS. And I think another thing that you see that is happening, right, from an IaaS PaaS application perspective is there's now a diverse delivery. We're not just talking about, there are now different consumption models, I would say, right? There is a delivery model, we talked about IaaS, PaaS, SaaS, but we also look at differences in consumption models. So people are moving towards a hybrid or edge computing model. And like I gave you an example, right? We see a lot of work in the cloud space around, edge computing or others. That is, if you look at what Googles of the world are doing, or Amazons of the world are doing, or Azures of the world are doing, they're now not just providing for a private cloud, right? They're not just providing software in a lot of cases, even they're actually providing you the whole rack, right? So you get the rack, you get the software and the hardware that you actually install in your data center, and you get the same feeling as and you manage it just like you're managing your cloud, right? And that's the next frontier as I see it, right? Because I think the adoption is now moved from this from the cutting edge kind of thing to bleeding edge to a model where the bigger long tail of apps are now going to be are now going to be moving towards the cloud. And to enable that, that's where cloud providers are getting towards, right? Saying, hey, we know you as a company need to adopt the cloud. You've got these applications, and we know you're not coming to the cloud. It's hard for you to migrate to the cloud. So how can we help you, adopt the cloud? And that's where this whole model of hybrid and edge computing is coming. And of course, we are getting towards an ephemeral infrastructure, right? Like I said, containers, functions as service, right? If you see functions there, especially if you talk about AWS Lambda, right? Functions at one time can only run for about a maximum of 15 minutes, right? And that's the kind of limit. So in such an ephemeral infrastructure, think about, and this hybrid infrastructure, and the fact that there's so many different ways you could consume the cloud. There's huge amount of complexity, and there are also new personas. I already talked about the developer, but now you have the DevOps, you have the DevSecOps, you've got lots of other personas who are coming in. One thing that we want to highlight here is that there's a clear asymmetry between the number of people in the security teams and the amount of applications and services that they have to manage and the infrastructure that they have to manage. There's a clear asymmetry. It's not like you could have dedicated people for particular apps. Apps are changing so fast. It's going to be a lot harder moving forward. We see there's that asymmetry is going to only go worse, and there's going to be a lot of need of automation, because of the fact that there's great complexity, and humans probably may not be able to deal with everything as is. So that's how I see it, right? On the application. On the landscape side, if you see, like I said, right, it's going to lead to a lot of automation. One of the key trends we see from a landscape perspective is things like objective-driven, infrastructure, but also objective-driven security. So instead of somebody having to write DLP policies, or somebody having to write, your file integrity monitoring policies, or your whitelisting policies, or what's now called allow listing, policies, or disallow listing policies, we are now moving towards an objective-driven security, right? Which means that instead of you having as a user having to do all this, right, for application that you don't even know. Right? Think of it. There are thousands of applications. You're getting things changing very fast. How are you going to know what file paths are allowed to do, file integrity monitoring, or what is the allow list for allow process, what used to be called process whitelisting, process allow listing now. Sorry, I'm just trying to sort of translate it to a more relevant term. So process allow listing, right? How would somebody know if the applications are changing so fast? And that's where this objective driven thing is coming, which is security teams do not necessarily need to know every policy that they set in. They need to know what they're trying to achieve. Is it PCI compliance? If it's HIPAA, it's if it's financial, I think I forget FFIE or whatever else other things that they have. They need to give their security objectives or compliance objectives or whatever else they may be, and the system actually takes care of actually setting the policies, doing most of these things, and that's how we see things moving towards, right? If you look at it from an infrastructure, like I said, we are already shifting left, and that's what we see in the security. So nobody is actually bringing up containers and bringing down containers manually, right? Containers are being brought up and brought down using Kubernetes. Kubernetes, you give objectives to Kubernetes saying, scale up if the load goes over 80%, scale down if the load goes below 20%, it automatically scales up, scales down. And these applications are being deployed at a very fast pace. And because these applications are living in the infrastructure at such a short time, you cannot just wait for the application to be deployed and then try to look at it. And what we are seeing is a big movement towards shift left, which is doing security not just in production but well before it is put in your production environment. So as soon as application is built, somebody can scan your software, scan your application, scan your container and tell you, hey, these are the vulnerabilities. As soon as your config is built, right, this is the config with which I want to deploy my containers or deploy my infrastructure. It's all scanned. The feedback does not necessarily come into the security teams alone. It actually goes all the way back to the developers. But even in this case, what goes back to a developer, what is allowed or disallowed is actually all managed by a security team. So the policies, the controls, the objectives are managed by the security team. But in a lot of cases, what we are seeing and what we see moving forward is going to happen is the security teams are going to be more like governors or governing this thing, and the people actually having to do a lot of the work may actually go down back to the developers or the DevOps teams or DevSecOps teams who would actually be able to do that. And from because of the fact that we have all these applications that are sort of changing very fast and so on, we see portability becoming very critical, and that's where you see containers gaining a lot of steam because it provides portability. It provides if you're using EKS on Amazon AWS, you could use with probably the same deployment scripts. You could deploy things on GKE on Google or AKS on Azure, and with little or no changes, your application would just be deployed, right, and would work for most parts. So that's what we see, and I think that's the other thing that we have to look at from a security perspective also, right? While infrastructure is moving that way, we also feel that security has to move the same way. That is, it has to be portable across these various layers. It cannot be like, hey, I'm only working on AWS or Google or Azure, because multi-cloud is a reality. Again, most of the reasons of multi-cloud is not because people are wanting to build an application on multiple clouds, but developers are using the best tool in the business, and in a lot of cases for say AI, they're using Google. For something else, they're using Azure, and for for certain other application, they could be using Amazon, right? And so that's where we see the landscape change. And if you look at the traditional tooling, right, it's not designed for such an environment, right? And so if you look at it from an IaaS PaaS perspective, like I gave you examples of disallow lists, right? You have blacklists of which is what anti-malware is or anti-virus is. It's very hard, right? Because applications are coming up and going down so far. The new applications coming up, new malware being deployed. How would I be able to secure things? So the traditional tools, right, whether it is firewalls, VPNs, anti-malware, has to sort of take a new approach. We see a set of disparate tools right now for different functions, but for different clouds, for different things. And our take is, as we move forward, that will not work, because it's going to be very hard to be able to use disparate tools, because applications are sort of moving around. Using tool for a particular cloud is probably not going to sort of help solve things. And the third thing that we see, and this is also very, very critical as we talk with customers, as we talk with users of the product, is there's in the cloud, with so many things changing, with the ephemeral infrastructure, there are way too many security issues and risks. For security teams, it's not just anymore about, hey, incidents. Tell me what, with my limited team size, what should my team be focused on, right? What is the thing that will help me reduce my risk the most? And that's what we see. And that's where we see the traditional tools not designed for the cloud fail. And this is where we see, and this term is actually coming from Gartner, which is CNAPP. But what we are seeing slowly, right, on a security side, there's a merging between workload, platform security tools, and data security tools. And I think what Gartner calls it is CNAPP. The basic idea is, there's going to be merging of what we call the cloud workload protection, which was the antivirus, the file integrity monitoring, or the workload protection things like process allow listing, hardening, right? That was what workload side. To the platform side, more like cloud security posture management, looking at the configuration of your cloud, looking at the configuration of your environment, telling any issues in that, as well as data protection, which is like looking at DLP, doing malware detection, doing looking at your storage buckets, looking at your databases, being able to detect the data. There's actually a merge of that, and that's what Gartner is calling the CNAPP, and we feel, right, that's where I see, at least from my perspective, that the world is headed towards, because you cannot have disparate set of tools, you cannot have disparate set of functions, and you need a way for various different things to come together. And if you look at the functionality of this, right, these are the functions that I see are important, right? The most important thing, and this is something that I figured out with security teams, right, in even our own, right, with McAfee, they do not have a way when they started off, right? They did not have a way to figure out, are there, and Jem can give you more on his experience with it, but we do not find a way where people have are able to discover all their assets. When I say discover all their cloud assets, it does not necessarily mean just accounts. In a lot of cases, people do not know if they are shadow accounts. They do not know whether there are services that are being used that they're not even protecting. Like, hey, somebody is using containers and I do not even have containers security enabled, or somebody is using RDS database, but I have nothing there. So discovery and, like I said, risk-based classification becomes very, very critical. And then, because there's so much risk, and you as a security team cannot fix everything, there's the whole idea of reducing the attack surface. And then, of course, like I said, from a data perspective, you have to sort of look at the data aspect of things to help you prioritize things, right? If you had an environment, say a test environment, running the same container and the same container running in dev environment versus a test environment versus a production environment, it is the production environment where you actually have critical data. That's where things are most critical. And so we need to bring all these contexts together. And that's why what we see from our perspective is, these things coming together and building on from there. So just to summarize before I sort of end it, is there's been a huge change in the cloud landscape in the last 10 years from IaaS, PaaS, SaaS. It's become, like I said, a multitude of different ways and mechanisms in which you can consume the cloud. SaaS is changing, not just, SaaS is no more just about application delivered in the cloud. It's also providing APIs in the cloud, right? So you have to look at that. From an IaaS perspective, it's becoming very diverse, very fast changing. It's becoming very hard for people to manage. So the discovery of those assets become the most important thing. And once you have discovery, you need a risk-based classification of your incidents, what you prioritize, have a mechanism to reduce risk by things like segmentation, and then, of course, look at data as well as merge things that you have, right, with like XDR, which is, hey, the cloud cannot be living in a silo, so incidents from the cloud or things that are happening in the cloud also get merged to your detection and response mechanism that you already have, right? With that, I'll just close my talk and wait for any questions, but if not, I will let Jem take it from there. Thank you, everybody.
Thank you, Vishwas.
So I don't know whether this is Srinivas here. I don't know whether I want to call this as a question or a comment, depending on how we can expand out on that. So when we were talking about this empirical nature of the overall cloud now, There are things which is coming in and going away and things like that. And obviously, as you mentioned, that security becomes an issue with some of those kind of things. And then you talked about this asset discovery with this frictionless thing. When things are so fast moving and when things are so temporary, how do you plan? How are people planning for security on that?
So that's correct. And that's where I see, so from my perspective, right, there are two parts to it. And if you look at the way things are going, my take is things have to shift left, right? Because you have such a short time, you cannot let things come into production and be running there. You actually have to put gates well before production. So in your test environments, you could be doing things, checks on, hey, what are the various components of your applications? You could be doing like whitelisting of processes. You could be looking at vulnerabilities in your applications, right? What are the components of your applications? What are the vulnerabilities in those things? So you'll have to do a lot of things left. You'll have to do a lot of democratization of security. That's one thing I see, right? Security teams can do controls and decide on controls, but in a lot of cases, who fixes that is not going to be the security team, but the developers themselves. So you have to actually involve, in my view, a lot of these developers, a lot of the other people, and be able to do things there. That's how I see it. Does it make sense, Srinivas?
Yeah, it kind of makes sense on the shift left thing, but that is what I would say pre-deployment, mostly pre-deployment thing. But after deployment also, there could be a rogue application or a, as you said, like certain additional assets which are there online and things like that. So then it could go down, come back after like 15 minutes later, it can come back and do something and then go back and things like that. So what it imposes is not just that part also, but I think it also imposes the overall nature of how, who and when, what happened.
Correct.
Which becomes huge. And the whole purpose of having a cloud for that itself defeats that, because you spend a lot of money trying to, a lot of effort and infrastructure to manage the total activity, whereas the use of that particular empirical nature is so small. The amount of investment and the kind of infrastructure which we put around to secure it becomes so humongous, then we don't know where is the balance.
And I totally agree with that. So the way I look at it is, right, and that's where the immutable infrastructure thing comes in, right? Instead of knowing every bad behavior which you cannot know, what if you actually knew how your application behaved? These are there's only, it's Nginx, it's a web server, and I already knew this thing only receives requests from external world and doesn't actually initiate a request, as an example. Or if I knew the processes running in your container and I was able to allow list it, right? What used to be called whitelist, right? Allow list it and only allow that to happen. That's how I see this thing, becoming, moving forward. I agree. If things are so ephemeral, how do I know what is bad or what is good? Because by the time I know what is bad, what is good, it's going to, go away. So how do I track that? And from my perspective, the way to look at it is looking at it from an immutable infrastructure perspective, saying, okay, these are the only things that are allowed because we've characterized and because of the fact that containers, right, in a lot of cases, application containers only have one process or two processes or three processes. In that case, what if I just use those three processes and only allowed those three processes and only allowed particular actions on those three processes based on what I know that those applications do? So there's going to be a lot of automation that that will need to be there to be able to look at this, right? Because from my perspective, no human will be able to know this. So there'll be a lot of automation that will be required to figure out what processes run, what is the behavior, what are the resources that these applications use, but then use a model of immutability, saying, okay, we've seen this application, it only behaves like this. Now, if I see something totally different, I'm not going to allow it. Or if I see a new process there, I'm not going to allow it. Or if I see something that is not good, I'm going to block it. That's how I see it. Mitten, did you have anything to add?
Yeah, I think it's a multi-fold approach you have to take. It's that not just the shift left, then you have to see runtime, then east-west traffic, and north-south. That's one, and then I think that's the basic or minimum, bare minimum. On top of that, you need AI or machine learning help, where it actually knows what was running actually 1 month back or 1 day back or 2 days back or 3 days back. what has changed? Is that something really trigger all of a sudden? And then you need to know the behavior of the change. If the change is bad change, so it will be like parametry, or it's a kind of a circle you need to put all together. So parameter, first control or hygiene your network, what goes in, then what is going in inside, and configuration. So like your runtime, you are doing NIST compliance, and somebody is watching it actually what is changing. So you can control it all around, and then it's automation. It's automation, AI, which learns and which detects. Another point I don't agree to Srinivas, like yes, I definitely see challenge moving to cloud, but the advantage, you need to balance with the advantage and disadvantage and where the world is going. So I think we have to move with the world, and where the advantage is so, I mean, so high compared to the risk, and if you have right tools, you can take care of the risk.
Makes sense. I mean, thank you. Thank you for the comments. I just wanted to understand your thoughts. Both. Thank you, Vishwas and Nitin. Thanks.
Thank you. Thank you.
Thank you. All right. Let's pivot to Jem's questions. Oh, sorry, Jem's presentation. We are running a bit behind, so maybe next time we'll schedule the meeting to run longer. We'll certainly continue to the end for this event and go past time so we can complete the content, and you know, hopefully you can continue with us.
Okay. Thank you, Vishwas, for the great presentation. Really appreciate it. Can everyone see my introduction slide?
Yep.
I can.
Cool, that's great. All right, thank you folks for coming in and listening. I'll be talking about cloud security challenges from a customer view. My name is Jem Gürkök, and I'm part of the board of CSA Silicon Valley. And generally speaking, we'll be talking about customer challenges, like the top 5 or so, how we prioritize them, because as Vishwas mentioned, we need to figure out where we allocate our resources and the possible solutions which we kind of touched upon and can apply. So generally speaking, we all know about these, but as a customer of cloud security solutions and the cloud itself, they don't really change. We basically need to make sure that the providers that we're using have proper, let's say, authentication authorization frameworks that they provide. Can we manage these things in a granular way? Can we integrate with our own identity providers? Do they even offer customization, or they basically make you use their own solutions? So basically, we want to make sure that we can integrate our own custom authentication authorization schemes. And if we don't have them, we were like a startup company, we might use what's being offered. Other thing that also Vishwas touched upon is the visibility and configuration management. So the visibility part is basically knowing what runs on your platform on the cloud, whether it's containers, whether it's serverless functions, whether just running services on running services on instances without much complication. We want to know what's running there. On top of that, we want to know how they communicate with each other, because basically, if we don't know how our services interact with each other, we won't know how to even secure them, because we don't know what kind of risk exposures these services have, whether they have, you know, public internet-facing endpoints, APIs, or they're just internally exposed. Things can change. Config management can alter security groups, for example, and suddenly your internal APIs are exposed to the internet, and that can be an interesting problem to have. Even if it's not your service API, things like your Docker daemon API can be exposed, and suddenly you have attackers uploading their own Docker images and running their own, let's say, monitoring solution in your cloud, and spawning off their own rogue containers. So being able to track your visibility and being able to track your configuration across time and realize changes and basically have only authorized changes happen, or even have, as Vishwas mentioned, an immutable platform where your configs are set at given times and only certain people can change this through approval processes. Another one is secret management. A lot of the recent incidents that have been taking place from a customer perspective challenges, the secrets are lying around on laptops, EC2 instances, even some public source code repositories. How do we even manage how our own payloads access these, let's say, credentials in the cloud as they execute? This is a challenge that, certain companies have their own resources to throw at, and certain companies that will just live off the cloud and use the cloud providers' solutions. Vulnerability management. This is another major challenge, whether it's just keeping track of your applications, your libraries that you're using, the images that you're consuming, like the container images, or even the virtual images or VM images, keeping track of those, their contents, whether they're up to date or they even have malware or they've been backdoored, knowing that is really important. Also on the runtime for the APIs you're exposing to the public internet, and also the ones that you don't know about, you should be able to track those and be able to patch them if there are any vulnerabilities found. Obviously, a lot of companies nowadays leverage the bounty programs. While that is somewhat provides you some visibility, that's not always the best approach. You always should invest in automated approaches. Another big challenge nowadays is companies want to exist and hold on to their on-prem resources where they want to store their privacy-related information, but they still want to make this available to their cloud environments. And whether they want to use it as an integration standpoint, integrate on the cloud with other vendors, or they want to basically process data in the cloud because it's more scalable compared to their on-prem resources. Providing that integration can be challenging. It goes together with the authentication authorization challenge, and as well as how do we secure the communication side? Do we do like a service mesh type architecture? Do we do end-to-end VPNs? So that is an interesting challenge from a visibility standpoint as well, because once we secure these endpoints, how do we even know what's traversing these the cloud and the on-prem solutions? The last one, which applies to a lot of companies that do user data processing, compliance. We have the California privacy laws, we have GDPR, we have other government rules and regulations that we need to keep track of. The major one being data privacy, and that is impacts, let's say, how we share data in the cloud. How much data do we store in the cloud, and how much do we keep on-prem? How do we review even the services that are spinning up and querying back our on-prem data or other types of sensitive data? How do we secure this data on the cloud? How do we encrypt them at rest? How do we encrypt them in transport? And make sure all these credentials of encryption, going back to secret management, are properly stored so that somebody who gets access to them is not able to decrypt them and view them. So these are, 6 of them. How do we know how to look at them from a provider standpoint? So Vishwas also mentioned we have various flavors of cloud offerings ranging from the SaaS platform infrastructure, depending on how much control we want on the services that we run or the infrastructure that we want to run. They offer various solutions that we can leverage. And again, this is generally speaking a well-known graph. Most of the time, the software as a service, when you're buying something from them, you don't have to worry about the security mechanisms related to the infrastructure. because you're buying the application. In a platform, you're just getting the means to run your services. And in that sense, again, while you don't have to worry about, let's say, running the infrastructure, you would still have to worry about the code that you're running on the platform itself. And you want to get visibility. You want to be able to manage your secrets, and basically the top two are constant across all three, the compliance measures and authentication authorization schemes. Infrastructure, generally speaking, you have to worry about all these challenges. But again, the question comes back to how do we prioritize these things? I'm going to shift into prioritization. Any questions so far around these challenges that I talked about? While they apply to regular IT infra, for cloud, it becomes a bit more challenging because we have multi-cloud, we have on-prem to cloud. You don't have any questions, it seems. We're going to move on to
one question I had, right? You said
yes, go ahead, Vishwas.
You mentioned that some of the data can only be kept on-prem versus kept on the cloud, right? What are the challenges of keeping things in the cloud? What do you see as the challenges there? I mean, what is not possible in the cloud, so you are keeping it on-prem? Go ahead.
Yeah, so generally speaking, it comes down to data privacy laws. So, like, for example, if you're serving customers in Europe, storing your data in a cloud that is hosted in the US, for example, can be a problem. So what you want to be aware is how your provider spreads your data, stores your data across all the geographies. When you're doing multi-regional deployments, you should be able to see where your data is getting stored or transported to, and be able to actually enforce rules that restricts where your data goes to. If you are able to store on-prem, let's say in Europe, you store European data in Europe, you know where it is. That way, the way you share it on the cloud, it is lesser of a problem when it comes to, let's say, compliance checks. You're like, hey, this is where we're storing it. Sometimes, and if you can only say we're processing things in the cloud in the European region of a given cloud vendor, that makes it a bit more secure. Obviously, their performance hits over there, but it's worthwhile from a compliance standpoint. Hopefully that answers your question, Vishwas.
Sure.
All right.
I think, yeah, so I have a comment. So we I know, so we do multi-regional deployment.
Right.
So the deployment itself, is a Europe deployment is in Europe, and then North America in North America. So that will automatically takes care of these, at least these issues, GDPR or the CCPA and others.
Yes, that is the hope. Certain companies have stricter regulations around how and where they store their information and how it's made available to even the platform owners themselves. So while we restrict access at the cloud level so it doesn't get spread out multi-region, the people who manage the infrastructure might be multi-region. So there are several other underlying challenges that take place there that makes it safer to host data on-prem. And again, it depends on your risk profile, which I'm actually going to segue into. Unless there are any questions. Cool. All right. So what really matters?
It looks like Naveen had a question.
All right, please go ahead.
Hey Jim. So the customer challenges which you have listed, right? Those are only like from an infrastructure perspective, or I mean, I didn't see anything specific to applications. So I was just wondering, because all bets are off. If your application itself is vulnerable, how much of an encryption we do. I mean, if the data can be stolen from the front door, all these bets are off the table, right?
Yeah.
So I was just wondering, is it just you're just considering the infrastructure challenges, or?
No, it's not only infrastructure. So basically, the data, it doesn't matter how much you secure your infrastructure. In the end, your data gets processed, And basically it comes by some, let's say, mechanism, whether it's a container or some VM, and what processes these becomes critical in case of a compromise. While you've hardened your infrastructure, if your service gets compromised, that attacker will have access to your data. So basically, you want to minimize how much the attacker can have access to. So for example, if you're able to minimize what your service can access by only providing a limited profile that can, let's say, touch only a given RDS or some other data store, basically you've only limited to that data set and not, let's say, your S3 buckets. So you want to have a limited exposure based on the identities that the services are running under. And it goes back to the authentication authorization piece and the visibility piece. You want to know which service identities your services are running under, and then you want to wrap those around with proper authentication and authorization. And authentication also covers the life cycle of a credential. Generally speaking, with service identities, you don't have users involved. So there is not much friction around renewing your credentials frequently. So you can renew your credentials every 5 minutes or even up to an hour or a day. It's up to your risk profile, obviously. But let's say when a resource gets compromised, if you're able to detect it early, you can revoke the credentials, and that way they don't have a long-living credential, or if the credential is stolen, again, it will be renewed, and the old one hopefully will be revoked and longer valid. So basically, it goes in layers. You secure your infrastructure, you encrypt your data in rest and transport, you use proper authentication authorization for your identities, and you have a tight, let's say, life cycle of these credentials where you have also good revocation mechanisms that are tied into your detections. So automation of detection and the response features that you have is also important, because in the end, as a previous guest mentioned, things happen really fast in the cloud with containers. Systems go up and down. How do you even know what happened? Who had access to what? So if you're not automating your visibility detection mechanisms, if you're not automating the response mechanisms, the mitigation mechanisms, then it will be difficult to do things manually. And unfortunately, there are a lot of companies out there, they won't know that they've been compromised for 6 months or even longer. And when the time they detect it, it will be too late. Most of their data will be exfiltrated at that point. So basically, authentication authorization across infra and services, proper visibility, type, credential, secret management, and also obviously, knowing what your services are vulnerable against and having a tight loop around patching, that becomes important. And hopefully that answers your question.
Yeah, it kind of does. Yes, I agree on all these points which you have mentioned, but what I want to say is like having like application security would also be of a paramount
yes.
importance. Basically, I was just wondering.
Yes, I agree, and although it's not obvious, the vulnerability management piece kind of covers that, where you would have a continuous monitoring of your services, APIs that are exposed, whether they're built in-house or exposed via the provider.
Right. I agree. Yeah. Thank you.
You're welcome. Cool. So going back to prioritization, these challenges can be daunting, especially if you don't have the resources. And you want to be able to prioritize and allocate the resources you have depending on what really matters for you. So how do you figure out what really matters? Generally speaking, you would like to do threat modeling. This is a term that's been used a lot for a long time. Some people find it boring, but the value of threat modeling has been recognized once again, by a lot of companies because it plays well with the visibility side. It brings awareness to the assets you own. It brings awareness to the threats and relevant risks to these assets. And then based on what you really care about, your crown jewels or other critical infra or services, you can assign priorities to these perceived threats and risks. This also drives your detection and response and preventive mechanisms. And then you can figure out where you want to spend more time hardening, building detections, and response. The other constraint, obviously, is while you've prioritized this, you might not have the resources to take on those top three. You might be able to only do one. And that basically the top one, you would allocate your security resources to, or maybe you would say, I have to grow the security software engineering team to be able to build better, let's say, authentication authorization infrastructure or better detection of pipelines and so on and so forth. Another thing that you want to know about is what are your gaps? What are your existing controls? And what are the things that you're missing as far as your visibility goes? Can you control even your cloud deployment in a way that is standardized across, let's say, all VPCs? Are you able to standardize your rollouts? Do you have control over who can make changes? Those are questions that should be asked and would drive the prioritization of these challenges. And I already kind of mentioned it, the asset side, and if you're able to identify your business critical assets and the way they're exposed, let's say, to the public internet, or they're exposed to, let's say, risky components of your environment. What I mean by risky is, let's say you're running code, or I'm sorry, you're running vendor binaries that are closed source, which doesn't have much trust in it, but you have to run it because that's the only way you can process data, for example, and it's a real challenge. Figuring out what these unknowns are in your environment, how they interact with your assets, definitely will drive it. Your challenge ranking and your prioritization of how you address them. And example questions that you can ask yourself as a customer, it's like, how do we post PII on the cloud? Do we even know what data we host there? What are the applicable rules and regulations going after the compliance aspect? Do we host third-party code or applications? I mean, a lot of people assume they are running their own code there, but developers who have, let's say, the move fast philosophy can package a lot of ready-to-use open source or closed source third-party code in there, and you'll never know unless you run a discovery and figure out the payloads in the cloud. Also, you should have a good understanding of the skill sets you have. You might say, all right, I'm going to run in the cloud, but on the other hand, if you don't have a security team that understands the challenges that come with running on the cloud, that might put you at a really risky situation because your security team, while you're deploying today, they won't come up to speed, let's say, at least in 6 months to build necessary detections or other response capabilities. And the other biggest question is, and we have to deal with this on a daily basis, there'll be risks that we won't have solutions as customers. What do we do with them? We will have to live with them to a certain extent, and somehow we have to accept these risks. And some of them have compliance implications, and we need to keep records of the acceptance of these, and we need to know what how long these are going to last for, because rules and regulations can change, and it becomes important to have leadership visibility and leadership acceptance of these risks, and not just blow through them without proper accountability. All right, possible solutions. We'll dive into things at a really high level. Any questions so far?
So you talked about risk, right, Jem? And you
Yes.
talked about mitigating risks, and some things that you cannot mitigate, you sort of note down, accept it, and
Yeah.
note it, take care of it, and at least have it noted, and have provide the data to your management teams and so on, right? But do you see things like transferring risk, or do you see mechanisms like transferring risk or reducing your attack surface by sort of are those also things that you look at? Or
Yeah, so depending on the cloud product you're working with, the transference of risk is possible. Let's say if you go with the software as a service model, you're transferring a lot of your risks to whoever's running that software, like your ISO 27000, your SOC 2 compliances, infra-related compliance risks you can transfer to your provider. But you would still be responsible around what data you're storing, who has access to that platform, your authentication authorization, and those first two layers of, let's say, challenges would still be applicable there.
Thank you, Jim.
You're welcome. So, I mean, this is a high-level table of what coverage you can get for these challenges on different solution platforms. Generally speaking, you have two options nowadays. I didn't include the third one, which is build yourself. And building yourself applies only to the companies that have the resources that can do that, in a short time. Most of the time, you have two options, meaning either the cloud provider is providing you with this capability, or you're buying a vendor product that will check the box for you. So authentication authorization nowadays is offered by most cloud vendors, and you can also buy third-party products that can help you with this feature. Going down the list, the one that's Vishwas mentioned the visibility and configuration management standpoint, where a lot of these products are converging to provide this visibility, what's running on the cloud, how your cloud is configured, and basically having a policy-driven approach towards this. The cloud providers are somewhat lagging there, but they're catching up. There are a lot of great vendor products that can provide, let's say, this capability, especially if you're running the platform and the infra side of things and you're managing your own components in the cloud. Secret management also is tricky. It depends on how much you want to trust your provider. Again, there are solutions like HSMs, hardware-based security modules that are offered in AWS, for example, or other providers. Or you can basically bring in your own services to the cloud that manages your secrets. Vulnerability management, generally speaking, since your services are pretty much custom built to serve your own purposes as a customer on the cloud, it will be up to you to figure out this vulnerability discovery, patching and management, also especially the application security side of things. There are great vendors out there, and one of our members here, the board members, works for a company, Himanshu, that is providing really in-depth services on this side of things. Yes, integration with on-premise resources, that's also another interesting part, which, well, before going there, how we integrate with the on-premise side. Do we integrate over the internet? Do we do peering, IP transit, or end-to-end VPN? This is up to how much, let's say, protection we want to offer to our resources, or how much we integrate with the public users versus business-to-business or on-prem to cloud integrations. Again, in this side, there are open source solutions that can help you build service meshes, which provide authentication and authorization schemes. There are other solutions that also provide visibility into your network traffic and some policy-driven access mechanisms. Again, this is provided sometimes by the platform itself, or you can get a third-party vendor or open source product to manage this. Kind of segueing into the evolving challenges. We already talked about some of these. The evolving space is revolving around automating these, let's say, challenges, how we detect the issues related to the challenges, how do we respond to them, because these cloud environments, containers, serverless components are really ephemeral. They go up and down pretty fast, and being able to detect things that go wrong with them in case of a compromise in a timely manner and responding to them, let's say revoking credentials, restricting access, let's say changing service group configurations in inadvertently exposed resources. So being able to detect these things fast and mitigating them is an evolving challenge, because a lot of these used to be part of third-party products. Now cloud vendors themselves are providing mechanisms that help you automate this flow based on config changes, mapping to message queues, and then map to, let's say, serverless function that can change configs on the fly for you without much manual intervention. Containers, serverless computing, this is something that's been going on for a while, but the adoption rate has gone up significantly. Unfortunately, as customers, a lot of us don't know how to manage these in a secure way. So spinning up Kubernetes in the cloud without proper locking down of APIs or inadvertently exposing these APIs can result in embarrassing situations. Again, it depends on how we are deploying these containers, whether it's managed by the cloud provider or it's managed by us in our own, let's say, Kubernetes clusters and instances. It will make a big difference as far as how much of the securing of this platform we want to worry about. The major cloud vendors out there are in the container side are providing an additional layer, for example, between the kernel and the host. So let's say they're both providing isolation for themselves and for their customers, in a sense that since they're multi-tiered, multi-customer environment, they don't want lateral movement happening across customers or across their own platforms. Things like Firecracker, Fargate, or on the Google side, you have gvisor. Those kind of additional kernel userland isolations become important, especially if you're running things out of the cloud provider. Zero trust networking, again, I kind of touched upon it a bit. Basically, instead of doing VPNs where it just opens the gate to everyone, to the resources, you want to have a tighter control on who can access what service. So it's not only authentication into your resources, but the authorization as to who can access what service and perform what type of action. And then backed by a trust, let's say, engine that can measure the endpoint's trust level, whether they are coming from, a geographic region that we don't trust, or whether the endpoints of that corporate user laptop are not trusted, depending on their past, whether they had malware on it or not, or they're running their proper security tooling on those. So monitoring these as far as accessing cloud resources becomes really important. Other things, I mean, cloud related, but not really platform related, is we have nowadays a lot of services that we leverage to do our day-to-day business, such as your documents, slides, spreadsheets. These are getting stored across multiple cloud providers. And being able to monitor how these resources are shared, locking down things based on policy access, it becomes critical, especially from a data leak perspective. You want to be able to make sure that the data that's not only part of your service is secured, but your day-to-day business data is also monitored and secured. I already talked about multi-cloud scenarios. A lot of, let's say, cloud vendors don't provide the digital forensics and incident response capabilities. So when an incident happens, you want to be able to easily access let's say, things like images or states of that given EC2 or instance, or dump memory, or basically look at traffic at a given time, or grab this network traffic and store it. That's later indexable and searchable. So while certain larger providers are providing these capabilities for you to do deep dive, except probably memory forensics, I would say a lot of the digital forensics capabilities are need to be implemented by us, the customers. And also incident response will also change based on the company or the customer and how their processes work internally. So that's something a lot of, let's say, cloud adopters don't consider as part of their security stance. Mostly cloud security is geared towards visibility, config management, and discovery of service vulnerabilities. All right. I think I've talked about containers at a high level, but how are we doing about time, Vishwas or Michael?
Well, we're past time, about 30 minutes. It's 5:30. So, I would encourage you to finish your talk, and then, anyone who needs to drop can drop. This will be recorded. We'll share it with anyone who's not able to attend to the end. Sure. And then, we'll get feedback, obviously, about whether the sessions, we'd like to keep them shorter, keep them at this length, and so on when we're done. Okay, sounds good. Thank you, Michael. So I'll touch upon really fast on challenges related to containers. Containers are basically namespaces and C groups that provide resource and runtime isolation for all processes or services that we run. And generally speaking, cloud and containers go hand in hand because cloud provides pretty much unlimited resources as long as you have money. And basically, to run containers, you will have to have an image or a base image that provides you the OS. Then you add on your, let's say, application framework like let's say Java, and then you throw in your code that is basically your service. And as all these are happening, you should be able to attest as to who is generating all these layers. Let's say the base image, generally speaking, should be provided by the company, built by a pipeline that signs this base image. And every time a developer adds an additional layer, they should provide a signing mechanism that basically can point back to whoever added that extra layer or extra code there. Vulnerability management, again, this is a good example of automation. Both the platform, cloud platforms and third-party vendors have done a great job as far as introspecting container images, whether they have vulnerable components or even backdoors, malware, so on and so forth. And they're able to integrate into your CI/CD development pipeline in a way that if any of these bad things are detected, it can block the container image from going to production. Obviously, in runtime, things can go south. Containers are just basically processes, and they can get compromised like any other exposed service. The question is, what do you do to prevent this compromise to spread across other resources in your environment? Basically, you want to do kernel, network, file system level isolation and be able to detect changes in your container environment through visibility and configuration monitoring. Because attackers, generally speaking, spin up their rogue containers that further start talking to your resources and exfiltrating data. Yes, we talked about policy enforcement, all these aspects. The solution that you're using as part of your cloud security deployment should be able to do policy-based enforcement in a way that blocks or disallows the risks. Yeah, the management side of the containers, whether you're using Kubernetes as a scheduler or you have your custom scheduler, you should be able to block access to the admin side of things. So attackers are not, once they gain access to your container, they're not able to actually change or add things to your environment through admin access.
Serverless is not so different. You're again running on containers, but it's transparent. It's in a sense that you're not really conscious or aware of it. You're just putting your code there, and the interesting part of it is that this is still vulnerable to code injection and unauthorized execution. Not many people consider this aspect of it because they think, all right, I put my code there, people can't change it, but it's still possible to modify the code on the fly. And depending on how you configure the role on the code is running under, you can have lateral movement or further compromise your infrastructure. So conclusion, yes, have as much as visibility and coverage across your infrastructure, and focus on your basic capabilities, lock down your endpoints or other resources with proper authentication authorization, know what's running in your environment, be able to detect these vulnerabilities and let's say remediate them or patch them as soon as possible. And definitely do a prioritization of the challenges you're facing, and then assign resources accordingly. So, okay, thank you very much for listening in, and please ask any questions if you have here or offline. I'm more than happy to have a conversation.
Very well, thank you. Thank you very much, Jim. Let's pause for questions.
Thank you.
If anybody has any questions, please speak up.
All right.
Okay, well, thank you. I will take just 1 or 2 minutes to close. Thank you, everyone, for your time. We really appreciate you joining us. We look forward to future discussions with you.